Hi, and welcome to Basler Electric Tutorial Series. Today we're going to talk about how to set up a bus differential with the BE1-FLEX. This particular example, I've already opened up HMI and loaded it into my settings file in BESTlogicPlus. And the application we're going to be looking at is a main breaker with 2 feeders and let's say a backup generator. So the bus that we're looking at is going to wrap around the high side of the incoming breaker and the low side of the 2 feeder and the generator. So first thing we're going to do is we're going to grab some hardware. So we want to look at bus voltage, so we'll grab a voltage. And actually going back, if we're looking at the amount of currents that we need, we're going to use 3-phase currents on each one. So 1, 2, 3, 4 times 3, we're going to need 12 total current channels. So I get 4 of them with my T3 board. I'll grab a X6 to get myself up to 11, and then an L6 to get up to 15, which is obviously more than 12. I'll go ahead and click Auto Generate Instance, and I will create some circuits. So I'm going to automatically populate that for me. And now if I look at my circuit summary, it's created 3 of them. The one that it didn't create as the 4th is because it doesn't necessarily confidently be able to guess which channels the last 3 currents are going to be used for the X6, so we'll create that one. So circuit 1, we'll go ahead and name that the main. We'll call that main. And it's looking at slot 7 voltage and slot 7 currents. So I'm not going to do CTs and PTs and all that sorts of stuff. You can view other videos for that. Feeder 1 is going to be slot 6, channels 1, 2, 3. And we have common bus voltage, so we can go ahead and apply that same slot 7 voltage here if we wanted to. And then we can get power information. Not necessary for the bus differential, but just generally good information to have if you have it available. Same thing for feeder 2. This one's looking at slot 5 hardware. Same thing, I'm going to go ahead and grab that bus voltage. And for the generator, this one hasn't been created, so I'll go up to Circuit Summary and create one, and we'll just call it Gen. Also, because we have to create it, we have to map some hardware to it. And if you recall, slot 6 was the one that had the extra current channels. So we'll go ahead and go up to slot 6 and grab channels 4, 5, and 6. So this is just mapping that hardware into circuits, and now everything I do from here on out is just going to be called main, feeder 1, feeder 2, and gen. Very straightforward. On the I/O standpoint, we're not going to be doing breaker status in this particular example. We're just going to be tripping bus differential relay, and again for that purpose we're just going to assume that we're going to trip a lockout relay, so we'll call it trip 86. And again, if you wanted to trip individual breakers, you've got a bunch of inputs and outputs depending upon your style configuration, but that's not specifically unique to the bus differential. So we can get into that in other videos. Next, we're going to go down into protection, and we're going to grab a, actually, I'm sorry, one of the things we did miss is under our style configurator. If we go back, we notice that the protection package is not enhanced, and therefore the bus differential is disabled. So once I click enhanced, I can just go to update instance, and it will now turn that function on for me in the settings. If I go to protection, now I can scroll down and I can see that phase differential as available to me. And I can call that bus differential. I can leave it at 87. It doesn't really matter. Once I add the function, I can go ahead and click the gray dot to start programming it. And this is where I get to select maximum or average slope. Again, you can get into the math on how to set this specifically. I'm just showing the steps in terms of how to implement it. So a zone is one of the key things into a differential scheme. And in this particular zone, I'm going to add 4 circuits. And go ahead and add those circuits there, and I can see them as coming across here. You can add as many of them as you wish. It's just dependent upon how many circuits you have available. I'm going to select the 4 sources I have, and this is going to define all the current in and current out of my zone. Circuit connection relates to a power transformer that might be in the zone. In my particular zone, I don't have any, so I'm going to set the circuit connection to all of them. What that setting is doing is it's doing the delta Y, delta zigzags, those types of transformations within that calculation. Polarity is important. So in common traditional bus differential, you're going to have all the polarities, facing, into the zone or out of the zone, depending upon exactly how your methodology is going to do it. But with bus differentials that are doing multi-purpose, such as feeder protection, and additionally, you might not be able to point all of your polarities exactly the direction you want them to. So you will use the polarity setting to, let's say, flip the polarity. The way this works is if they're all set to normal, that means all of the currents are going to sum into each other to create the differential current. If you have any of them set to reverse, that's going to take normal of main and actually subtract feeder 1, subtract feeder 2, and subtract generator. So in this particular scheme, all the polarities would be, from top to bottom, having the same directionality. And again, that has to do with the directionality in terms of the currents, and you can simply use that setting to flip it. Automatically calculated, if you have a transformer in the zone, you can use the automatic tap calculations. I didn't set up CT ratios, but we're just going to assume all the CTs are the same. But if they were different, and you could see it here, and utilize the taps to normalize those currents if you wish. But again, in our example, we're just going to assume that those are all the same CT ratios and they're 1-to-1s. Finally, we're going to go down to BESTlogic. And in BESTlogic, we're just going to grab some very simple logic. We're going to grab that 87. In my particular case, we didn't actually give set points to it yet, but I suppose we could. So if we're going to go back and give it a minimum restraint, let's go to 0.25. I'm just making up arbitrary values at this point. A couple slopes in there if you wish. Second slope, multiples of tap, let's go to 4. Unrestrained tripping, if I wanted to do an unrestrained at, let's go to 10. Again, I'm not picking intentional numbers, just trying to show you how you would generally go about putting set points into a differential element. There's also transient monitor to detect CT saturation and other things that are very specific to differential relays that we can get into fine detail later. Now when I go back to my 87, I had set up the trip and I'd set up the unrestrained trip. So I'll go ahead and drive both of those. And in my particular application, I only really care about tripping that 86. So I'll go ahead and grab that 86. And that is the settings that you have to do to implement a bus differential in the BE1-FLEX. Thank you very much.